Welcome to the second video, and let's start with the second portion of our proof, which is after knowing the graph, actually doing something with the graph to find the center. So what we have always heard of is a partially differentiate. Okay, wait, sorry, I forgot to bring up my picture. I will just do that. Okay, where is that? Where is that? Where is that? Where is that? That. Where is that? Where is that? Where is this? Is this? This is it. This is it. Yeah. So yeah. Drag it over here. Nice, 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 nice. Very nice, very nice. Absolutely beautiful. Yeah. Done it. Hmm. Uh, so we have always learned to partially differentiate this graph, assuming z to be a constant, and then uh, show that this is 0, and then solving this and this equation together to find the center. And that goes the same way for any hyperbola. Doesn't need to be doesn't need to be written like a standardized form. Like, it can be written in any form, and the same uh, stuff that we need to do to find the center. And the same goes for that kind of representation too. The only difference between that kind of representation and this kind of representation is you can always transform that kind of representation by transformation of axis, or like rotation of axis, by multiplying with that matrix of transformation, that cos sine and minus sine cos, that matrix is a nice way to transform. Let's not go there. What I was saying is, we solve this and this equation together to find the center of the conic. But what do this equal to 0 and this equal to 0 and solving them together mean? Let's visualize that with the help of this graph. So when you differentiate it with respect to y, assuming x to be a constant, what you end up at is this equation, right? So x to be a constant. So let's assume x to be a constant and x to be a 2. Okay. So x is a constant right now along this plane only, obviously. Wait, what happened? Okay, it turned light. Yeah, for all the values on this plane, x is constant. And so intersection of that plane and this curve would lead to all the point on this curve, which actually have a constant value of x2, that is 2. And when you see, it's a downward pointing parabola, right? Why is this a downward pointing parabola? That can be realized if you see right here. Like, if you assume x to be a constant, this is kind of a constant, right? So this is a constant and this is a constant, and we manually vary this. So this is a variable and this is a variable, and they are dependent. So we end up having an equation which is kind of like this, which evidently has a minus sign over here. Let me zoom it further so that you can see it has a minus sign over here, which would represent it's a downward pointing parabola, and not necessarily vertex at the origin. Remember that I say not necessarily at origin, but it can be at origin. I think so. Yeah, I know so. Sorry. Like when x is 0, that can happen. And similarly, when you assume y to be a constant, this whole thing turns out to be a constant, and this is obviously a constant, and that way you end up having some equation of this kind. Sorry if I forgot to write minus c here, which would correspond to this value, it having a minus sign in front, up front I mean, and that would be the upward pointing parabola in xz plane, or some plane that's parallel to xz plane. Let's see if that's the case here. Like, if you assume y to be constant, It is evidently a upward opening parabola, to be precise. So yeah, what we were doing before this is we were saying, what does this mean? What does this equal to 0 mean? So when you say this is 0, what do you mean is z doesn't change as you uh, do slight movement along y-axis, right? Along y, right? And here we assume x to be a constant, so we can just evidently uh, evaluate the equation along this plane, and then generalize that for every plane, right? Yeah, this is 0 means the point is right here, the vertex of the parabola where the slope is 0. This means the slope, right? But along zy plane. Yeah, so this thing represents this point. And when you do that for all the values of x, you will end up with a curve which kind of looks which will be this curve, and it will extend till infinity. And when you uh, get the projection of that curve on the xy plane, remember that's what we are interested in, because z is not just a coordinate, it's like a factor by which you scale up or scale down. So let's not consider z totally. So yeah, uh, this curve's projection on xy plane would yield this x-axis. And remember, this x y is equal to 0 means x-axis only. So this equations mean this axis, and this equation means this y-axis. And when you solve them together, you actually end up getting uh, 0 comma 0 comma z value. Z is just a factor by which scale up or scale down. And the same is true for like all the values of z, right? Because changing the values of z won't change the actual derivation part that we took to reach here. And the only thing that will vary is the actual value of z. And as I told earlier, we won't be considering it because it's just a factor. Yeah, so that yields. And now let's talk like why should that equation give the center. For that, I would need to like remind you of the definition of the center, which is the point of intersection of all the locus of midpoint of a set of parallel chords. What that means is, for a given hyperbola, you can make infinite number of infinite sets of parallel chords, right? For this particular case, I'm taking the chords to be parallel to y-axis. Sorry, and like this. So it goes till infinity like this. And when you join their centers, you will end up with the x-axis, and this is it. And similarly, when you do the same for uh, the other one, this one I mean, you will end up uh, having chords which are parallel to x-axis, and like this, and they go till infinity. And when you join them, you get the y-axis, right? And obviously the y-axis and the x-axis will intersect at 0 comma 0 and some value of z. So yeah, uh, that's a neat way of like visualizing as to why the center should be uh, got the way that we get it. But now at least you have some intuition as to why that should be true, right? Thanks, and that's what my aim was, to be precise. uh, so see you in some next video. Bye.